Welcome to this Cognite webinar. It's Peter Jacobsen talking here from Cognite. Today's webinar we have called How Would Unsiloed Data and Modern Software Change Your Maintenance Processes? And I think unsiloed is a bit play of words, but everybody knows what silo data is, so I guess everybody understands what unsiloed data is as well. And our subtext, we have get a closer look at the maintenance process in heavy asset industries and how to improve it with new technology. So first, some housekeeping. The webinar will be about 40 minutes. We will do 10 minutes open Q&A. So please post your questions in the question box in the application that you are using to see this webinar. A link to the video of the presentation and the webinar will be shared with all the participants or with all of you after the session. And also for more information, etc., reach out directly or visit cognite.com for more information. If you go to cognite.com, you will find this. Cognite is about making data do more in asset-heavy industries. We do that in essentially two ways. We have Cognite Data Fusion, which is a data platform to make all industrial data accessible, understandable, and useful for engineers and developers. And we have Cognite applications that then take those capabilities into an operational context. We work with customers in asset-heavy industries all over the world. Some of the most digitally ambitious companies in industry, and this is something that we are very proud of. Cognite Data Fusion, it makes data available, it makes it useful, and those capabilities that Cognite Data Fusion will give you, they represent potential to improve operations through performant contextualized data, through efficiency in solving use cases and getting to digital improvement, and also visual data and user interface capabilities. We then use those capabilities also ourselves to build modern software to integrate data in a process, an industrial process context, and to take those capabilities to the front line and to assist in transforming industry. And that's also what we will talk about today in Cognite Maintain. So Cognite Maintain is our maintenance application to break down traditional data and organizational barriers and to bring AI and seamless collaboration into your maintenance process. We have with us today, in addition to me, Peter Jacobsen, we have, and we will turn on cameras now to say hi. We have Mari Sofie, we have Ashutosh, and we have Dan with us. So first, Ashu, who are you?
Yes, my name is Ashu. I have a background from oil and gas automation and maintenance. In Cognite, I've mainly worked with project management, working with delivery of digital transformation projects, mainly in oil and gas. I have almost 10 years experience. Have worked with ABB, mainly in commissioning engineering of process automation systems for oil and gas industry. I have masters in systems engineering from NTNU in Trondheim, where I worked mainly with machinery and system data for failure mode analysis, also for oil and gas systems.
So I think we can call you a maintenance expert.
Not sure about that. Yes.
And you, Mari Sofie?
Yes, so good afternoon, everyone. My name is Mari Sofie Korsten, and I have nearly 10 years experience from the oil and gas industry, working predominantly with significant transformation projects, most recently within the digital sphere, and have taken several products from the MVP phase to an operational state. So here at Cognite, I hold the position of product manager for Cognite Maintain. I look forward to sharing my insights with you here today.
And last but not least, Dan.
Yeah, my name is Dan. I'm a senior software engineer here at Cognite, and I have been working on Cognite Maintain for the past year.
Okay, so let's get on with it. So today we will talk about the maintenance process in asset-heavy industries. And let's start from the start here. Asher, can you take us a bit through the maintenance process and how it comes together?
Sure, Jakub. So the maintenance process, like many other processes in the heavy asset industry, is based on the plan, do, check, act philosophy. The process consists mainly of different softwares, procedures, and most importantly, people. To start with, the asset and maintenance strategy at plant, system or machinery level is typically established during plant startup based on a mix of inputs. Number one, the recommendation from OEMs during the engineering and commissioning phase. And number two, using the reliability engineering tools like criticality analysis, reliability centered maintenance, failure mode analysis, etc. However, it's also very common to start establishing a maintenance strategy during the plant life cycle. The underlying data used in this process is either from plant operations or from databases of historical failure data where available. The next step, after you have set the maintenance regime and maintenance strategy, is establishing maintenance plans, both preventive and corrective. And these are then recorded in CMMS, which is a centralized maintenance management system, or in many cases, enterprise asset management system, EAM, where you also find spare part information and documentation stored in the same system. And thereby, this system plays a central role in steering of plant maintenance and asset management. In this step, also, condition monitoring systems are used to implement the maintenance for production critical equipment, especially rotating equipment like turbines, compressors, etc., and high voltage electrical systems like switchgear and transformers.
Correct.
For planning and scheduling of maintenance tasks based on maintenance plans, which is established in the previous step, different tools are available, especially for offshore operations like oil and gas and wind, where logistics are more complex because of a mix between offshore, onshore engineers, and third-party service engineers. The important systems here are CMMS. You have spare part management system for procurement of tools and material needed for doing the job. So basically arranging parts and permits. You have document management systems, so PNID, certifications, etc. You have project planning and management system, including personnel management, and most importantly, hazard identification and risk assessment for these jobs out in the offshore, in addition to schedules and 3D models of the facility for bigger modifications. Once these tasks and work packages are planned and scheduled, then comes the implementation. So the offshore technicians and service engineers responsible for the implementation print out the documentation, checklists, and permits. The area should be cleared and isolated if needed, in addition to reserving the material and tools needed for the job. During the shift change, also the technician has to document what has been covered in the last shift. And during handover, this is more critical during for control room operators, because the operator has to document and hand over what was done in the last shift.
Okay, so yeah, that was about planning and execution. So how do we work on improving the maintenance and kind of the effect of our program?
Yeah, that's a very good question. So then comes the most important part of the loop. That's analysis and improvement, where the goal is to measure effectiveness of existing maintenance plans and improve them continuously, thereby increasing the system or equipment reliability. The most important steps here are collecting the data, preferably according to ISO 14224, the standard for data collection. Second, and also very important, checking data quality. And third is analyzing that data. This means, for example, optimizing existing strategies and changing the maintenance intervals using data and domain expertise, or moving from corrective maintenance like run to failure to preventive maintenance strategies like maintenance based on running hours, calendar-based inspection, or condition monitoring. So condition monitoring traditionally consists of vibration monitoring, oil or lubricant analysis, motor current signature analysis, etc. And for high voltage machines, it's about partial discharge monitoring. or thermography. Typically, maintenance organizations look to close this loop by feeding the operational state information into a system that can dynamically change the maintenance strategy in CMMS for continuous improvement. In an ideal scenario, KPIs can be measured not only for improving reliability of the machinery, but also for different parts of the loop, like planning and scheduling, to monitor effectiveness, and that can be used to make the process even more efficient.
Great. It sounds like a somewhat complex process for at least an outsider. But what software is involved here today?
So yeah, going from the left, first you have to establish the reliability and maintenance strategy. So some of the softwares available here are ReliaSoft, ARMS Reliability, and in many cases operators use Excel sheets. Next comes the implementation of established strategy, and then you have the EAM CMMS systems, which is used to record the PM and inspection strategies like SAP, IBM Maximo, etc. In this step, you also have execution of condition monitoring programs, and in there you have systems like Bentley Nevada, SKF, Enlight, Fluke, and other types of electrical monitoring by HPPD, Qualitrol, etc. Next comes planning and scheduling of the tasks and work packages related to maintenance.
So it's quite a lot of software involved. I think we can conclude with that.
Definitely.
You mentioned that the objective of the maintenance program is to minimize the lifecycle cost and to maximize production output.
Yes.
And in that sense, if you take, for example, condition monitoring, the promise here is to do more adequate maintenance activities based on the actual status or condition of the equipment.
Mm-hmm. Yes, indeed. So taking a very simple example, Peter Jakob, a pump can fail in 5 different failure modes. And one of the failure modes is, for example, misalignment. In order to detect this failure mode, one can set the maintenance strategy to do a periodical detailed inspection once per month. If the pump is not failing often and that data is not being collected in a structured way, then it will be difficult to improve the strategy. On the other hand, if the technician is collecting the data from inspection, then one can automate that analysis and increase the inspection interval failure data systematically to find the optimized interval. In this case, the change in interval is written back from optimization application to CMMS so that the work order creation is updated. In addition, data can be also collected from control system automatically to further improve maintenance and reliability. In the case where pumps are critical and have a high cost of failure consequence, a vibration monitoring system can be set up, and the results can automatically trigger work orders in the CMMS system using write-back mechanism. The example emphasizes on having a common underlying data foundation with data coming from different source systems contextualized in one layer with write-backs from applications to the data foundation, so that all the applications can use the enriched data and not end up siloing the enriched outputs.
Understood. And if it's been a lot of talk, at least over the last some years, about predictive maintenance. I'm not sure if it's that new as a concept anymore, but if I call that in a sense condition monitoring, but into the future, with again just a promise to do more adequate maintenance activities, would you regard that as accurate? Or?
Indeed, Peter Jakob. So I believe it is a good way of seeing it. And yes, good maintenance is about optimizing a set of activities that balance lifetime cost and maximum productivity. And the information necessary to optimally do that resides in different systems, as you have seen. And it is a lot of manual iterations. Lots of different systems, definitely. And it is a lot of manual iterations before a plan gets executed, for example.
Okay, so I think we have kind of a detailed understanding now about the process. What would it take to transform it? Is there anything more we can do that really provides a step change, Marie-Sophie?
Yeah, I certainly believe so, Peter Jakob. And based on the complex landscape that you just covered, Ashu, I think it's safe to say that there is some room for improvement, to put it mildly. And let's divide it into 3, as seen in this slide. I believe number 1 is understanding that whatever we do, it needs to result in changed activities. Because let's face it, building the most novel AI does not provide any value unless it ends up changing the activities executed in the fields. It's basically these guys in the picture whose day we're ultimately trying to improve, right? Number 2 is acknowledging that all of the information necessary to plan these activities is hardly accessible to any given person, which results in non-optimal plans. This problem is only emphasized when conditions change and result in unplanned maintenance. So fundamental to well-arranged maintenance activities is data integration and getting the most out of your software stack. Then number 3 is to start generating more data through 1, cheaper condition monitoring, and 2, collaboration to start building positive information feedback loops. But we need to start with number 1 and build from there. And this is really where Cognite Maintain is key. So everyone, let me show you what I mean. So as you can see here on the screen, this is the landing page of Cognite Maintain. And you can see that really the 3D model has been given center stage. Let me just state for the record that the value of Cognite Maintain does not rely on having a 3D model. Here we can leverage other drawings, document types. In this case, it's 3D. But okay, let me assume now the role as a maintenance planner. This is all nice, right? I see my data contextualized, it's visualized, it's coming from SAP risk systems, project, 3D, whatever, but I need to drill down. So my scope that I want to optimize today is the next 7 days. Hence, I can pick from this list a set of predefined lists, of course, customizable, and I can see here the lists, and I can also explore them on the 3D model. But okay, this is the list I have from my CMMS system, right? I want the data to work even better for me. So that's why we've included the suggestions element here. This is, of course, populated with several different elements that you can get suggestions based on. For the sake of this demonstration, we'll have a look at the first one. And here at the top, we see why the work order is suggested to be added to your scope. For instance, we see that it is in the proximity of one work order that we already have in the scope. Hence, it would make sense, right, to do it at the same time as our guys and gals are out there in the field still. And it will also bring me slightly closer to my goal loading for my electricians. So I agree with the tool. I will go ahead and approve this change. And yeah, for the time being, pretty happy with my scope, which takes me further to the next step in the maintenance planning process, and that is namely scheduling. So here we can see the sequence of events, as it were, from the source system. We have the scope listed up above with our 10 work orders for the next 7 days. And further in the bottom of the screen here, we see the capacity load for our different capacity or disciplines required to fulfill this scope. And the traffic lights, of course, they imply whether the loading is appropriate or not. We see that our welders are having a bit of a rough time on the 17th and 18th of October. So let us then expand on these work orders and do some alterations so that we are setting the stage in an improved manner for pleasant execution in the field. And then finally, I have now updated my scope. The schedule works. Finally, I will save it. And of course, mark the value as to why I did this change. Very important enabler for realizing and tracking the value generated by digital transformations.
Okay, great. I mean, this looks really cool. And then you could also see any kind of machine learning models or predictive maintenance models running and get them into the same scheduling process, right, Marie-Sophie?
Yeah, indeed. And more importantly, this contributes really to closing the gap between the field and the office. This is a known challenge, right? Take a concrete example. A maintenance job has been scheduled and it requires materials to be performed. The information on the materials' whereabouts as we all know, reside in several different systems. So sometimes the planners just have to assume that the tools are at the location, just for reasons of time and complexity in checking for every single task, which in turn results in that activities will be scheduled where the resources are not in place, which of course is a huge annoyance. That is why we have, of course, included a material status in this tool. The data exists, right?
That again, it comes from the source system.
Precisely. This is all fetched from the source system, everything we see here, but it's really just contextualized, right? The data exists, so why not liberate it and let it become useful for everyone instead?
I've spent literally days of my life looking for containers on drill ships, so I can definitely relate to the logistics issue and assuring that things are on board when you should start working.
Indeed, and what we see here now, right? We have the container ID, we have the quantity, everything is there. So I'm not surprised by what you're saying, Petter Jakob, but this is namely why we have included it here, because setting the stage for pleasurable execution is key to good activities planning. And this really means bringing the field and office closer together. Contextualized data being the bridge builder in this case.
And where do you think we can gain the most, Ashu? Is it better planning, better scheduling, or is it letting condition monitoring and the subcategory predictive maintenance create a more dynamic maintenance program, or where is really the value here?
So our belief is that it is all coming together, right? Let's assume for a second that we increase the share of condition monitoring by a lot. Basically, we have cost-efficient ways to scale data science and physics models, and because they have more predictive power than what has been previously the case, that will then create, like you say, a much more dynamic maintenance program with a larger amount of activities coming in with a short lead time, which of course has a real effect on scheduling, which needs to take into account that right people and equipment are present, the other activities that are being performed, which might represent risks or opportunities, etc. In that scenario, the only way to keep a healthy risk level is efficient scheduling software, like that was shown previously by Maria-Sofia. That has all the live context and assists the planners in getting the sequencing and parallelization right. So essentially, we need to raise our capabilities in these fields at the same time, Petter Jakob, to create something transformational.
Yeah, no, that makes a lot of sense. What about the more detailed planning, like isolation plans and so on?
Well, in a perfect world, in equipment maintenance, you have mapped all the failure modes, at least for all the critical equipment. You have a plan in CMMS and other systems for each failure mode working seamlessly, in addition to all these activities that are done periodically, right? In reality, there will always be unforeseen events where also the planning needs to happen very fast.
Indeed, and we are actually working now on automatic isolation plans as we speak. Because as we utilize a very performant industrial graph database in Cognite, we are able to represent flow relationships, electrical connections, etc., which at its full potential is the needed foundation for auto-creating isolation plans and just pushing them as activity checklists to field workers. So in other words, this is the direction we are going. As you can see here on the screen, with the P&ID view, of course, contextualized as well, representing the relevant data. And this is again, like Ashu was talking about reducing the time from seeing a maintenance need to being ready to safely executing the maintenance in a more dynamic future. Jakob.
Okay, great. And what about, again, the improvement part of the maintenance process, as you showed or talked about earlier, Ashu?
So, Jakob, in the process picture, improvement is shown as a very stepwise process where you analyze and then improve. We also believe a lot in continuous improvement. And of course, there is no need to remove yearly analysis and improvement of the maintenance program as a strategic exercise. But we believe a lot of improvement potential lies in creating a continuous feedback loop. And the core of that is really the facilitation of communication. So we integrate with Cognite Infield, which is an application for field workers, and are building in modern ways of communication with tagging, etc. So we can use the communication to enrich the data. So we have to analyze and to create constant positive feedback loops between the field and the office.
Cool. We actually did a webinar on in-field yesterday, so it's available on demand on the webpage for anyone interested in that as well. Okay, so tell me one thing. I'm hearing about called digitalization fatigue, among the industry frontline, who has just seen, I guess, too many empty promises or empty drones or whatever you will want to call it. So how do we assure this, this novel technology, let's call it, is actually being used?
I think digitalization fatigue, it's a very good term, right? And I think it's very much real. And indeed, adoption is key. Anything novel we want to achieve starts with somebody using it, right? That's just how it is. So this is something I'm extremely focused on. And there are three important perspectives here, as I see it based on my experience. First, top down. It always starts at the top. Management need to articulate the why. Why is it important for us to change? Why have we chosen digital? And why the particular focus areas? Yes, I know everyone is doing it nowadays, or at least trying to, but it is crucial that top management connects it to the specific company, its operation and goals. Make it relevant and ultimately personal. However, let's be honest, if you think having the CEO announce that digital transformation is underway and everyone will follow without any further reservations, I'm sorry to say, but that the level of naivety is quite high. This is by no means sufficient, which takes me to the next element, bottom up. In order to successfully achieve digital transformation, you must obsess about your end users. And my personal mantra is that when the user is happy and her problems are solved due to the products we deliver, then I'm happy. And a happy user is, in my experience, an extremely efficient change agent within his or her organization. And last but definitely not least, let's not forget about all of the layers in between. Engaging managers as close to the end user as possible has proven to be a very effective way to get usage up. Because let's be honest, we are much more prone to acting on a message from our direct manager than from the CEO. And we have in Cognite experienced this many times, and we are more than happy to be there alongside you, helping you along the way.
That's great to hear, and great to hear that you also have these experiences from actually implementing software on the sharp edge of industry. I have one question. Can we take a look at the roadmap of Cognite Maintain applications?
Yeah, sure, but Jakob, I can definitely share some points on the high-level direction that we are moving in for Cognite Maintain. We are working on improving the business case of monitoring through better data science and hybrid models, and the ability to scale deployment over your asset base. Here we're also engaging with partners to integrate their models to have one place to orchestrate the monitoring, regardless of third-party models, Cognite models, or customer-generated models. Hence, we need to improve our scheduling capabilities in order to further develop Cognite Maintain to make optimal use of the vast amount of data represented in the tool. Creating an optimal plan, always ensuring safety based on live data. A feat that is impossible to tackle for a human being without software support. We want to maximize the value that lies in data, always leveraging it in its freshest and most live form. And then we need to improve the cross-application collaboration to get solid improvement feedback loops. And on an asset level operations, all come together across disciplines. So we are looking at better integration with Cognite Best Day to more dynamically handle the production maintenance interface. And I would just like to point everyone to the webinar we had earlier this week to check it out, to see what Best Day is all about.
I think it's a great direction that you're going in, Marie-Sophia. It's really exciting. But you also brought with you the guy, I think, responsible for making it happen. So Dan, you are the tech lead, I've been told, on Cognite Maintain. For us non-techies, what is that? Is it like a lead programmer? Or
yeah, I mean, you can call it a lead programmer, a tech lead, like development lead. I mean, companies tend to have different naming schemes for these kind of roles, but overall, my role entails the implementation of the application and guiding that. whereas the product manager might ensure that we are building the right thing. I ensure we build it the right way using the right methods.
Great. Welcome to you too.
Thank you.
And you, before Cognite, you came from outside of industry. So what do you think is different inside of industry?
Yeah, so I came from insurance and media industries previously. I believe one of the more fascinating things about the oil and gas industry, as well as the other kind of more heavy asset-based industries, is just the sheer amount of data that is available to play with, and we do play with it. We do have a lot of fun playing with this data in a lot of cases. Like the time series with decades-old data points, with millions of new data points being generated daily. Thousands of actionable work orders being produced, as well as hundreds of thousands historic work orders we can learn from as well. But I mean, with that comes the challenge of displaying such a massive amount of data to the user in a way that is easily digestible, not overwhelming, and of course, still technically feasible.
And you know, as a programmer, what is key to creating world-class industrial software from that perspective?
That's quite a question. Yeah, so I think anyone who can code can create industrial software. If you can program, you know, JavaScript, HTML, you can make a piece of software. But the differentiator, I think, of becoming world-class usually lies outside of that code. Taking an example, myself and the team, I truly believe we've become junior maintenance planners whilst working on this project. And that comes with being able to gain that basic domain knowledge of the field you're creating software for is so important to making sure you're creating the right things. That, alongside building very strong relationships and ties between the relevant domain experts and the subject matter experts, the people you're building the software for, and the end users, I think that is key to becoming, you know, getting the highest kind of quality out there. But I mean, from a more technical side, ensuring that you're managing this massive amount of data efficiently is also vitally important. You know, there's a lot of data to manipulate. There's, I think, over 50,000 work orders possibly just active today, and that manipulation of those work orders can take a couple of seconds, and that may not seem like a long time, but to an end user, that's a couple of years. It feels a long time, and your users shouldn't have to suffer through that. Those crucial seconds are important to optimize, and figuring out the best way to optimize and offload those tasks off the application can pay dividends to the end user experience. And through that, what is of course important is to have a strong backend supporting your front end application. And that's where Cognite Data Fusion, or CDF, is so crucial for what we do. And we wouldn't have been able to do it without it. Like, the speed it delivers the data to us is incredibly impressive.
Great to hear. And okay, one question that I have, and I'm used to working in the oil and gas industry, and that many companies, you know, they like to do things their own way, let's say. Do you think the processes and so on are similar enough for this to be a valuable proposition across customers?
From experience so far, and I can speak on behalf of perhaps Mai as well, we certainly believe so. The processes are real. They deal with real physical things, pieces of equipment. We perform activities on these pieces of equipment. We have risks to deal with, dependencies to deal with, people and resources to deal with. I mean, the differences are mostly semantic at this point. For instance, the software used to document the risk might be different, but the risks are real and essentially the same. So I believe we effectively solve this through, one, efficient data integration, for which, of course, Cognite is fantastic at, and two, customization for each client as well. It's also important. So, I mean, overall, from our experience, we've not had any issues so far.
Cool. And you know, what does it take to get started?
You contact us. That's really it. I feel comfortable that we can guarantee return on investment in 6 months, and I can discuss the details with anyone who wants to hear.
Very good. And also, I think feel free to contact any of us. You told me, Mari Sofie, to say that, but you are, you want to talk to potential end users or people in the maintenance process to learn how you can kind of improve your roadmap even further and so on. Is that right?
Absolutely, Peter Jakob. I'm just so really passionate about being part of this. We really do encourage anyone to reach out, get in touch, have a chat, and the time really is now.
Will we be able to transform maintenance?
Most definitely. I'm convinced of it. And the time is now. We have the software, we have the sense of urgency, and we have the opportunity. So I urge you all to partner up with us at Cognite and come change the world.
That's great. I really like the passion, Mari Sofie. So thank you everyone for listening in. The 27th to the 29th of October, we will have Ignite Talks online conference. There will be 22 sessions over 3 days with more than 50 speakers from companies such as BP, Saudi Aramco, and Aker ASA. So just go to cogniteignite.com and join the talks. It will be very interesting. Other than that, let's open up for Q&A. And I see we have gotten a question here that I think is good to, well, it's to all of you really. But how long would it take to get Cognite Maintain set up for my company?
Given what we've experienced so far, I would say it would take somewhere along the lines of 6 to 12 weeks, approximately. That is to ingest all the data, set up the application, put it into the format we want and need. Yeah.
And in this element as well, right, it would be also very relevant for us to speak to end users at a given company to understand what customizations would make most sense, right? Because the end users are really of the utmost importance. They are the ones who are going to use it and ultimately generate the value.
And there's also this element of building custom models here, Ashu, that I know you have quite some experience with.
Definitely. So what we need basically is more data on failure modes, domain expertise, and club that with the data available and contextualized in Cognite Data Fusion. Once we have that, then that will be the driver of scaling machine learning models to all the equipment.
And okay, another question came in here. How easy is it to integrate into my existing data sources? I'm not sure, maybe for
it's quite a
well, there's a technical side of it and it's an administrative side of it, I guess.
From the technical side, of course, it depends on that data source. We already have experience integrating several data sources already, SAP, eCal, Primavera, and several more. If there's one we've already integrated, then it will certainly be expectedly easier to integrate it fairly quickly. If it's a new one, if it's one we haven't encountered yet, we'll certainly integrate it one way or the other.
Great. So we will end on that note. Thank you very much to all of you participating, Ashu, Mari Sofie, and Dan, and thank you also very much to all of you listening in. I hope you have taken in some new perspective on how we can transform maintenance, something we are really passionate about here at Cognite. And again, I'd like to emphasize that feel free to contact any of us if you have opinions on the webinar or the direction we're going, or want to have a chat in any way. Reach out, and we'll be more than welcome to set up a talk with you. So with that, we'll end. Thank you, everyone, and thank you to the participants today.
Thank you.
Thank you.
Thank you.